Physics, chapter 22, theory video 4. Here we are going to now compare between electric fields and gravitational fields. Now we saw that there are many similarities between the two. So now we are going to figure out what these similarities and whatever the small differences that are there, we have to understand those. So the main difference between the two is in electric fields there are positive and negative charges. So as a result there can be uh, repulsions as well as attractions. But in masses, because there are no negative masses, we only talk about attractions in gravitational field, right? Uh, Now, later on, this is something that you might in another couple of years or maybe even 100 years, we might realize that there is something that goes against the gravitational field as well, but that is not yet discovered or that is not yet theorized. So that is something that we might have to discuss in the future. But for now, what you need to remember is there are no gravitational repulsions. As a result, we talk only about gravitational attractions in gravitational fields. So the let's compare these two now. The gravitational fields, it has the origin from in its masses. It arises from masses. Then electrical fields, it origins from the electric charges. Then vector forces, only gravitational attraction, no repulsion. Then vector forces, both electrical attraction and repulsion are possible because of the positive and negative charges. Then all gravitational fields, field strength is equal to G equals F upon M, force per unit mass in gravitational field. In electric fields, it is E equals F upon Q, force per unit positive charge. So that is those two equations you need to remember for both of them separately. Units are, therefore, force is in newtons, G is in newtons per kilogram or meters per second squared. So that is, those are units in here. In this units in electric fields, units force is in newtons, E is in newtons per coulomb or volts per meter. Then uniform gravitational fields, parallel gravitational field lines are available, and as a result G is constant. Then uniform electric fields, parallel electric field lines are there. E is equal to V upon D, which is a constant. V upon D. So here we are talking about the difference or the gap between the two charges. Then spherical gravitational fields. We discussed the radial field lines. Then we gave an equation for F. F is G capital M simple M upon R squared. Then radial field lines, we gave the force an equation F equals Q1 Q2 upon 4 pi omega 4 pi epsilon O R squared. Then field strength is obtained in gravitational fields. G equals capital G capital M upon R squared. Then field strength in spherical fields, we took it as E equals Q upon 4 pi epsilon O R squared. Because gravitational fields are always attractive, we show G on a graph again R against R as negative. But in because there are negative charges that gives an attractive field and a positive charge that gives a repulsive field, force and field strength obey an inverse square law with distance. So as a result, we have two negative curve as well as a positive curve. For positive charge, positive curve. The negative charge, it's a negative curve. Then gravitational potential and electric potential, they have their own equations, Gm upon R and Q upon 4 pi epsilon O R. So these potential is a scalar quantity, is a scalar quantity and is always negative. But in but in electrical potential, it obeys an inverse relationship with distance and zero at infinity. It is the same thing for both gravitation and electrical. Potential is a scalar quantity. However, because there are positive and negative charges, there is a positive as well as a negative curve. Right. So those are the comparisons that we need to do. Right. Then these values, proton mass, proton charge, epsilon O, G, those are values that you have to remember, and also they might put these questions together, gravitation and electric fields, they might combine these questions, and then you will have to identify them separately and do it appropriately. So one thing that you need to remember is whatever they whatever they give, you have to remember the separate equation separately. So in summary, we discussed Coulomb's law. The 2 point charges exert an electric force on each other that is proportional to the product of their charges and inversely proportional to the square of the distance between them. So we obtained an equation for that, F equals Q1 Q2 divided by 4 pi epsilon O r squared. Then for a point charge Q, that gives a radial field, and the electric field strength, we got an equation for E equals Q upon 4 pi epsilon O r squared. Then the electric potential at a point is defined as the work done per unit positive charge in bringing charge from infinity, where the potential is zero, infinity to the point. Then the electric potential for a point charge is given by V equals Q upon 4 pi epsilon OR. Then the electric potential energy of 2 point charges is W equals Q1 Q2 upon 4 pi epsilon O R. So these are the equations that major equations that we discussed. Then all the other sub equations as well you need to remember. Please go through the chapter once again and do the end of chapter questions. If you have any further questions, please ask.